Use definition 3.1 to find the slope of the tangent line of the graph, the equation of the x-coordinate of A. So, with that said, the limit as, what is it? H or A approaches 0? H. The people in the back talking who did not get A's or B's on their tests, zip it up. Limit as H approaches 0 of f of A plus H minus f of A all over H. The function is, funny, this is somebody's question in the back and they're chit-chatting. The limit as H approaches 0, square root of A plus H minus the square root of A all over H. Fantastic. When you do this problem, you realize that the problem is when you put 0 in for H, you end up with 0 over 0. So, who solved it without looking at the student solutions? I didn't ask if you did. I asked you did it without. Yeah. What'd you do, Alex? What'd you do? Conjugate would be square root of A plus H plus the square root of A all over square root of A plus H plus the square root of A. When you multiply out by the conjugate, you do not have to multiply out the denominator. That's not the problem. You multiply out the numerator. And we talked about when you multiply by conjugates, you end up with the first term squared, which will give you A plus H. And you end up with the last term squared, which is A, and there's a subtraction sign between them. Well, you still have an H down here multiplied by the square root of A plus H plus the square root of A. And using your keen sense of algebraic skills, you know those will subtract off. You know the H's will divide off. So it leaves you with 1 over. The H's will divide off, giving you a 1. This will turn into a 0, 2 square roots of A, or 1 over 2A with the square root of A if you rationalize it. Okay? Probably should. If Nick Glover was here, he'd rationalize it, so we might as well. I did too. Easy. You just showed how easily distracted you can be. Back to focus. I am. Because stats didn't go well. Ready? Part B. Find the equation of the tangent line at P. Remember, this is A, f of A. If I put in 4, I get out 2. This point is on the graph, which makes it nice. So for part B, find the equation of the tangent line. This gives me the slope of the tangent line is the square root of A over 2A. The point is 4, 2. You need to answer the equation for part B. Y equals MA x plus B. I know the y value is 2. I know the x value is 4. The slope of the tangent line, well, if you put in 4, don't you end up with a half? Let's see, 2, a 4, right? So the slope equals 1/4. 1/4 plus b. So b has to equal 1. When you solve that, b equals 1. So it's going to be y equals 1/4 x plus 1. All right? Is there a C? Sketch the graph. Oh, a square root, everybody remembers, looks something like this. Go over 2, up 4, make a dot, and then there's your tangent line. Right? Oh yeah, 4, 2. There we go. 4, 2. Perfect. All right? Nice. that basically sums up what we talked about, except for the conjugate, but still sums it up pretty good. I just had a question and trig today about the conjugate. We had to use it. Hopefully I'll finish this up. If not, I'll get close, and we can get moving again. We did that one, did that one. I don't think so. All right. Sketch a graph the equation for the tangent lines with coordinates -2, -1, 1, and 2. Okay, the equation is y equals x cubed. That's not too difficult. Now, -2 would be at -8. -2, -8. Then you have -1, 1. -1, 1. Yeah, 1, 1. And then 2, 8. And you're supposed to sketch the tangent lines. Well, this one's going to have a pretty steep slope, but be positive. This one's still going to be positive. Notice how it goes through the graph? It's tangent at the point, but it can still go through the graph. That's not that big of a deal. At 1, 1, tangent again. And at 2, 8, tangent yet again. So it kind of is difficult to see, but, bless you. The one thing to notice is they're all positive. They all have positive slopes. They're all going up, which is kind of weird. They all have positive slopes. That's interesting. All slopes are positive except zero. The x equals 0 is called a plateau point. It's kind of a resting point, then it goes up. Yeah? Because anytime you look at a line that goes up from left to right, it's positive. If you look at a line that's going down from left to right, it's negative. Oh, because if you're sketching a graph that's tangent right here, you can't make it negative because it'll go through the graph. It has to go with the graph. And if the y's are increasing from one to the next, that's a positive slope. So anytime the y's are increasing, even just a little bit, it's going to be positive slope. It's when the y's are going down. If the y's are decreasing, that would be a negative slope. Okay? So you can look at the y's, or you can look at the curve itself. Now the reason I said that about 0 is because on both sides of 0 it's kind of flat and goes straight across. Find the point on the graph which the slope of the tangent line is given number m. How would you do that? This means m of a equals 9. What is a? Yeah? Right. Remember we had the slope of a equals the limit as h approaches 0 of f of a plus h minus f of a all over h. If you don't know this by now, you better know it by the end of the week, or hopefully by Wednesday. Now I'm going to put 9 in place of this, and f of a plus h, I'm going to put a plus h cubed minus a cubed all over h for the limit as h goes to 0. Can anybody guess what's going to happen now on this equation? It's called an equation because there's an equal sign. And there's really only one variable to solve for, and that's a. Everybody knows the h is going to divide off, and everybody knows how to cube this out. Yeah? How do you cube it out? Yeah. So 9 equals the limit as h goes to 0 of a cubed plus 3a squared h plus 3a h squared plus h cubed minus a cubed all over h. I told this to last year's calc class, and I told it to this year's trig class, but I haven't said it to you yet. It's going to be interesting how this book goes, considering you were the first class to have this author as a trig textbook. Yeah. So that problem was hopefully an extension of the other book. So that was my goal anyway. The a cubes will divide off. The h's can be factored. So I have 9 equaling the limit. As h goes to 0, take out an h. Put in 0 for the remaining h's. Some of you need to make a note to yourself because in the last test you stopped right there. Let h equals 0 before you write your answer. Otherwise, you're going to bring up h's with the a's and you won't know what to do. So 9 equals 3a squared. A equals 1/3. A squared equals 1/3. So a equals root 3 over 3. Oh, 3. Yeah, I was all excited about the rationalization. That's okay. Let's see. 9, 3, plus or minus root 3. Okay? Nice. That's what a equals. It doesn't ask for what y equals, so pretty well done. How many you can find y? You just put it back into the equation. All right? Limit definition of derivative. You're going to have to use this on the next test, and you won't be able to use any shortcuts that you might know or will learn. All right, we're moving on. Excellent. The position function of a point moving on a coordinate line is given in t seconds, and that's the t in centimeters. Find the average velocity of p in the following time intervals. These are t is in seconds. You know that is x. S to t in centimeters. You know that is y. I'm going to do something just a tad bit different, I think. Oh, anyway, there's two different parts. One's the average velocity. You remember how to find that? I could call somebody right now not paying attention and embarrass them, or somebody else could answer. Who wants to answer? Average velocity. Nobody knows. Nobody wrote that down. I said, write this down yesterday. Yeah. What? Right. F of B minus F of A all over B minus A. Or y2 minus y1 x2 x1. See the words? I did so. The average. I said the average rate of change. It all means the same thing. You could do this if you wanted to. Delta y, delta x. A lot of people were rushing last weekend. They were talking about the deltas and all that stuff. How do you find the velocity in part B? Somebody in a maroon shirt, not on the volleyball team. Ha! If you should fall, goes to Taylor. Yeah, for part B, you use the limit as h approaches 0 of f of a plus h minus f of a all over h. That is velocity. That's all you have to do for A. No. You have to solve it. That's how you're going to solve both parts. Okay? You need to solve it. That's how you're going to solve it. So, for part A, very good. I like that. That's for people who don't see really well. All right. Now, why is my calculator out? Because I feel like being lazy. 2x 2x minus 3x squared. Okay? I'm going to go to the table, set. I'm going to do the ask again. I don't want to know everything. I just want to know a few values. All right? So I'm going to go to the table, and I'm going to go 1. I put ask. I'm going to put in 1, 1.2. Actually, check that one. We'll go in order. 1.01, 1.1, and 1.2. Okay? Make sure you have your equation of y equals. Anybody else get those equations? All right? So, to find my answer for A, if I'm talking about the interval from 1 to 1.2, I'm going to use the interval from 1 to 1.2 and find the slope of the line. So I'll take the difference in y, the average rate of change, I'm not going to spell this out every time, is negative 1.92 minus a negative 1 all over 1.2 minus 1. Okay? I just took the difference in y's, divided by the difference in x's. That's all. Well, it comes out to be negative 0.92 divided by 0.2, which is what? 4.6? Yeah, negative 4.6. All right? For the 1 to 1.1. I use the x and the y values that are given to me in the problem. So, in this case, since I'm after the 1 to 1.1, I use the 1 and the 1.1 values. You can compute them lots of different ways. So I'll take negative 1.43 minus negative 1 all over 1.1 minus 1. So I get 4.3 is my answer. Is that right? Negative 4.3. I mean, you get 0.43 divided by 0.1, so 4.3, right? And for part C, 1 to 1.01, so I'm going to use these 4 values. Negative 1.04 minus negative 1 all over 1.04. Wait a minute, that's not right. 1.01. How's everybody doing? So you end up with 4, negative 4. Yeah, you end up with negative 4. Is that right? Oh, I get a lot of hesitation on this. Huh? Okay. You know what? Oh, no, I just got the y values on there. Oh, I went to second table set, ask, second table. We just typed in the numbers 1, 1.01, 1.1, and 1.2. I just use those numbers. Okay? All right. Part B. Now, what do you think these numbers represent? Yeah? Sure. They represent the what? Average rate of change. Table set, ask. I have to type in different numbers. 1, 1.1, working. Try it now. Oh, mode. Float. There you go. That's what you got to do. All right, you're welcome. These are the average rates of change. Now, where do you think the instantaneous rate is going to be if t equals 1? What do you think the instantaneous is going to be? Tangent. Probably around -4 or something, don't you think? Now, for some of you, this is the first time you've had this difficult of an equation to do as far as finding the slope of the tangent line. So watch very carefully the algebra. Ready, Graham? Good. Limit as h. 2a plus h. You have to put the a plus h in for both of them. Not just one, but for both. Minus 2a minus 3a squared all over h. Now it comes down to just algebra. Remember, you're trying to find the slope of the tangent line at what value? 1. So when I get done, we'll put 1 in for a. 2a plus 2h minus 3a squared minus 6a minus 3, whoa, back up. That's 3ah minus 6ah 3h squared minus 2a. Close on my algebra? The a's go. Same with the 3a squareds. Remember, after that step, you should have nothing left except for something that has an h in it. Every term should have an h in it. It's built that way to be successful. Cross those off. The h's, what happens to them? They turn to 0. So you're left with 2 minus 6a. Put in the 1, you get -4. Obviously, later on in this chapter, you'll be doing that a lot quicker, but for right now, you have to practice the algebra using the definition. Questions on that? That's the instantaneous rate of change. That's the velocity at 1. Right. It's your first time in doing stuff like that, where you have the 2 and the 1, things like that. Pretty good. Ready to go? Questions? What? It was. The only thing that's better is a question about Sam Gilly. Look at this. An athlete, I put this exact question on last year's test. And you know only 50% of the kids got it right. This exact question because I knew we did it in class. An athlete runs, whoa, hey, whoa, this way. You're going to miss it. An athlete runs a 100-meter dash in such a way that the distance run in 2 seconds given by this. Find the athlete's velocity at. You should be able to do all 3 of those parts now within 3 minutes of start to finish. 3 minutes. Find this. Find the athlete's velocity. Velocity. Which definition was it from 2 slides ago? A or B? It was B. Okay. The word average isn't in there. So we want to find the velocity using this equation. All right. Oh, no. Use this to answer all 3. So let's get started. You don't need it's in your book, number 18. The limit, we'll open it. H approaches 0, 1/5, a plus h squared plus 8, a plus h, minus 1/5, a squared plus 8a, all over h. Yep. Nope. At the start of the dash, a would equal what at the start of the dash? 0. In part B, a would equal 5. In part C, a would equal no. How'd you do that? No. How fast do you think Sam can run the 100? This is why only half the people got around the test. You read the question, but you don't really understand what it means. This is the distance traveled. If you set this equal to 0, all right? He hasn't gone anywhere, so it equals 0. When you solve this equation, 0 equals 1/5 t squared plus 8t, how do you solve that? Quadratic. Or you can factor. In any case, a will equal 0. After 5 seconds, how far has he traveled? Well, 25, that'd be 5 plus 40, 45 meters he's traveled. I put 5 in for the time. So he's gone 45 meters. How do you know when he finishes the race? How far has he traveled? So set 100 equal to 1/5 t squared plus 8t and solve that. How do you solve it? You all have the ability because I gave it to you last year if you want to do it quick. Pick up the calculators, punch it out, and solve it. Because once we find the answer, once we find the velocity, the equation, we can plug in those three numbers and get our answers for A, B, and C. So what is the what is the time for this one? 10. So now I know that when I solve this equation, I want to find the slope when 0, at 5, and at 10. That answers part A, B, and C. In this textbook, if there's a B or a C, you're going to have to do some work before you get the answer. You're going to have to think, what does this equation mean? How does it work? Now you go back to this. Once you find this equation, that gives you all three answers. The limit, as h approaches 0, 1/5 a squared plus 2/5 ah plus 1/5 h squared plus 8a plus 8h minus 1/5 a squared minus 8a all over h. Again, the algebra should be easy. You all have algebra credits. The 8a's dropped, the 1/5 a squared's dropped. Time to factor the h. 2/5 a plus 1/5 h plus 8 all over h. I got wrong? I factored an h out. That's okay. So the h is gone. Remember, this remaining h goes to 0. So I have 2/5 a plus 8. In a word problem, you need to have a unit on your answer. So for part A, Sam is going at 8 meters per second. What? How can you be going 8 meters per second? We haven't even started yet. It's a term you heard in physics. Close. Oh, I thought you were going to say the answer. Initial velocity, the oomph with which you start. That needs to be written down somewhere. Initial velocity means time equals 0. Okay? Initial velocity. Oh, I saw something really cool yesterday. I'm going to bring it up in part B or C. It was really cool. I had to look it up on the internet as it was going on because I didn't understand it. Part B. You put in 5. And what do you get? He's picking up steam, coming into his own, pulling away from the pack. 10 meters per second. Nice. And C? No. He ran it in 10 seconds. And what's C? If I put in, what is it? 12 what? Still going strong, 12 meters per second. And then if he dives like a try, he gets 5 points. Did you all see that yesterday besides me? Or just me? I'm talking about when you're running and picking up speed, and when he wins and he crosses, if he's carrying one of those rugby balls and hits, it's counted as a try, and you get 5 points. However, if you cross the line and you're tackled and the ball doesn't hit, you only get 3, I think. Rugby. Yes. Yes, the World Cup. No? What kickoff? Oh, sometimes. It was kind of boring. This isn't boring, though. This is pretty cool. Oh, if you haven't seen any, you need to watch at least 30 minutes of a match to appreciate it. Not in rugby. I like it because they don't get bailed out, not like in football. Yeah, and they get stomped. Some guy came in just and took the ball away. It was great. Oh, yeah. It's encouraged. Huh? All right, do this one on your own, please. Do this one on your own. You can do it, Grizz. Give it a go on your own. Yes, only it's not as much. It's fewer problems within one problem. In the back. Give it a go. No, you're not. Push that pencil. Give it a go. You know what to do? I think you do. That's the answer for part A. I just found the y value, subtracted them, and divided by the difference of the x. The equation, 3 minus 2x squared. Yeah, y equals. I said function notation. You know how it goes f of x. So you go to bars, y bars, function, y1, parentheses. Okay. Down here, the leftmost endpoint of the interval will be what? 2. Yep. Yeah. It didn't go. Now it will. 3 and 3, factored out. Just because what the directions say. So it's negative 8. So, good. The average and the instantaneous, pretty close. They should be. But you've got to know the difference between the average and the instantaneous. The answer for part A, I got negative 8.8. Well, I said negative, didn't I? Oh. And the answer for part B, I got negative 8. One's the instantaneous, one's the average. All right. 5 minutes? Great. We don't have time to do this. Spartans, no retreat, no surrender. All right, get to 23 odd. What was it, 13 to 23 odd?